In this block of instruction, I'm going to go over the three main signals that a fire alarm control panel sends. It's an alarm, a trouble, and a supervisory. Now by code, an alarm signal has up to 10 seconds to enunciate the panel. A supervisory has up to 90 seconds to enunciate the panel. And a trouble has up to 200 seconds to enunciate a panel. Now, by code, all three signals have to be different. And when I mean different, the sound, the tone, the LEDs that illuminate on the panel, and I'm going to show you first a trouble. And what I'm going to do is I'm going to pull this NAC circuit here. And as you see, the beeping, it's not fast, it's not constant, it's a little slower. The LED there is lit up trouble. Now, if this was a panel and you were doing an inspection, let's say you pulled a NAC circuit, here I'm going to silence this. If you pulled a battery, pulled a horn strobe off the wall, has up to 200 seconds for the panel to enunciate. If it doesn't, it fails. Same thing as clearing a trouble. If a trouble's present and you bring whatever state was in trouble back to normal, it has 200 seconds for the panel to clear. Now I'm going to put this back. There it goes, it clears. Now, supervisory. I have a little switch right here to represent a supervisory, whether it be control valve on a riser, phase reversal, power loss on a pump controller, even your duct detectors if your AHJ allows you to program those as supervisory. Now, it takes up to 90 seconds. Now you see, this LED is lit up for supervisory. That tone, it's in yellow, but it's faster than what the trouble was. It has to be distinct. Now, I'm returning it back to normal, and it clears. Now you have a different type of supervisory. You have a latching and non-latching. If it's non-latching, that means like here, it's off normal condition, back to normal, and it clears itself. If it's latching, if I was to return it back to normal, you still have to go back and reset the alarm panel. But again, 90 seconds once that device changes state to enunciate a supervisory at the panel, and then once it clears, if it's non-latching, has up to 90 seconds to clear at the fire alarm control panel. Now we're going to do an alarm next, and I'm pulling the notification circuit just so that we don't get our ears blown off here. I'm going to pull this pull station. Now if you see here, this is a constant tone. It's different, it's distinct, and it's lighting up red. All new fire alarm panels, if you have a fire alarm, it's going to show red. And then we can silence it. Pull station's back to normal. Then we reset it. I'm going to turn that back to normal. Now, an alarm signal has up to 10 seconds, again, to enunciate the panel. And a lot of inspectors out there, especially when water's starting to flow, are checking their watch for 90 seconds for it to initiate a flow switch. Now, for a flow switch to initiate a fire alarm panel can actually take up to 100 seconds because you've got 90 seconds for the water flow switch to initiate from water flow, and then an additional 10 seconds for it to initiate the panel. Now, I'm going to go over the three most common ways that a fire alarm panel is monitored. You have your onboard DAC, which is your digital alarm communicator transmitter, and you have cellular, and you have IP. Now, most panels today have an onboard DAC. Your onboard DAC is your phone lines. Either be copper or you can use a cellular communicator, which is in place of those copper phone lines. And whenever you program, you put in your 4 to 6 digit account number, and you have to put in a primary and secondary receiver numbers. That's telling this panel where to transmit signals to. Now, 10, 15 years ago, it was all copper lines, onboard DACs, but now a lot of these phone systems are being transitioned to voice over IP. Voice over IP runs off your internet, and I don't know too many networks that are 100% fail-proof. So most fire alarm panels do not like voice over IP phone lines because they don't carry that consistent 35 to 50 volts DC that this onboard DAC checks for every 15 to 20 seconds. It does a voltage check. And every time it does a voltage check, if it doesn't see the voltage, you're going to have telco issues. You're going to have communication issues. That's why a lot of people are using cellular communicators. Whenever you use a cellular communicator, you have to make sure it's rated for fire, because they do have them for intrusion. They have them for even residential. But it has to be a UL listed, fire marshal approved fire communicator. Now you do have newer panels that have IP communicators directly on the panel. Like I said in my class, I highly, highly recommend, if you use IP, to use it as your primary means of communication, not your backup. By code, each panel has to have two means of communication. You have your primary and your secondary. Your secondary is used for when the primary fails. Being IP and being over a data network, if it goes down, you don't want that to be your backup. Your backup needs to be your fail-safe. Another way, which is still digital alarm communicator, you have outside transmitters for, let's say if it's a 2 or 4 zone panel, or it's an older fire alarm panel that doesn't have an onboard DAC. Most of your panels have relays, and on this panel you have an alarm, trouble, and a supervisory relay up top. Now, and when I mean a third-party communicator or outside communicator, it's things like a 411 Firewatch. It's a small little piece of equipment where you hook phone lines into it. It has an onboard DAC that you can program the receiver and account information into. But let's say this is a panel that doesn't have its very own onboard DAC. It has 3 zones where you'd run wire and you would put it on the alarm, trouble, and supervisory contacts. Now, in this instance, it's only going to give you a general alarm, a general supervisory, or a general trouble. It's not going to be able to give you the contact ID reporting and tell you there's a NAC 1 trouble, there's a NAC 2 trouble, alarm module 4 second floor. It's not going to give you that distinct information, but it will monitor the alarm, trouble, and supervisory relays on your panel. So when it goes into alarm, closes that circuit, creates a short, and then it reports the alarm. Supervisory, trouble, same thing.